All right. Hello, welcome. So we have Chris Ross and Sam Spencer on. We're going to be talking about Yarp. I'm not sure what's happening. We don't seem to be live on Twitch right now, and I've double checked all the settings and things. And I'm not sure. So I will mess with that for a second. We are also, we're at live.net. So let me check that.
It looked like it was running when I checked a minute ago.
On Twitch?
No, on live.
Okay. Yeah. So this is strange. I double checked here. Let me take one more look at that because we do have a good Twitch contingent that loves to come and watch. We even, of course, we always test all this stuff out ahead of time, but you can't test what's going to happen when you go live. Okay, so Visual Studio. Interesting. Here, I'm going to try this. Reconnect. I don't know if that'll break things. No, I can't do that. That would break all the things. I'm not sure. I don't think I'm going to be able to change any. Let me click one more random setting here. Yes. Okay. Yeah, there's nothing else I can really do here. So I guess we'll just go for it, and we'll be live on YouTube. I will tweet about that, and then we can jump right in. Okay. Sorry about the silliness here. Okay.
I'm assuming this is recorded as well.
It is recorded. Yep. And, that's always something. We get like 90+% of the views always are people watching the recorded version. So, all right, let's jump right in. I'm going to, as always, start with the community links. So I will share my screen here. And here we go. All right. So, as always, the links are shared via the URL list. So I will share the links in the chat, in the description, everything. They're always there. So let's run right through. First of all, we'll start with a fun little discussion here. Andrew Locke starting things up fun with a should you unit test ASP.NET API and MVC controllers. And, really, really interesting discussion. He kind of goes through the things that you actually would test. I've seen, there's definitely, that was a thing about MVC. I remember when it was kind of first created was like, hey, it's all unit testable. But in reality, I was writing a lot of unit tests that said, does it return the view? Yes, it returns the view. And there's not really a lot of value in that a lot of the time. So he goes through and kind of deconstructs what you're not testing. You're not testing routing, you're not testing model binding. Those are all framework level concerns. You're not testing model validation, you're not testing the filter pipeline. There's all this stuff that happens and you're not testing and you shouldn't test. And so then he goes through and talks about what you are testing. And, the focus here of, are you testing thick controllers, which you really, it's kind of a bad practice generally to have a thick controller. A controller should really be working with services and repositories and things like that. So, so then, what you end up with is your controllers really should be pretty thin. And what you really want to be testing is either the services or the interaction level. So he kind of ends up there talking about the testing at the integration test level. And, he calls out to Steve Gordon's recent course, and I featured that as a link previously. And also he calls out to Khalid Abu Hakma's recent post, and his post is just a bunch of different tips, but one of his things is favoring integration tests as well. So a lot of good stuff there. So interesting post to get you thinking this morning. All right, here's a fun one. So Matthew Jones has been doing some recent posts on games using Blazor. And so here he's looking at Yahtzee. And it's really interesting looking at making a game, because you end up with these interesting domain modeling constraints that you would normally kind of work around or not, think, I don't have to deal with this. But going through and looking at what he's modeling here. So he's starting this one. This is the first in a series, and he's looking at the model. So he goes through and just does all the domain modeling. So going through, and it's interesting, you can go through and you can look at a scorecard, or you can teach a kid to play Yahtzee in a few minutes. But when you actually go through and break down what the model is doing and what all the rules are, it gets more complex. So he goes through and defines, what's involved in a play, what's involved in winning, what's involved even in the simple things of modeling the dice. And so then, wrapping up at the end here, we go through some things with like, how do you tell if somebody even has a full house or a straight? And so, so that at the end of this, we have a model complete, and then he's going to continue on in the series. So fun stuff. Speaking of games with Blazor, so here's David, and he's talking about game dev. This is part 9 of his series, and here he's looking at a finite state machine. So, part of just running game logic, you often end up with some sort of state machine, and so he's looking at a finite state machine and how that's modeled. And his posts in this series are all pretty short. There's a decent amount of code, but they're really kind of bite-sized. So I encourage you to kind of go back through. Here we're jumping in at number 9, but you can go through and you can look at previous ones and step your way through, and they're kind of easy building blocks. So, all right, and last in this little chunk of Blazor things we're looking at. So here Niels is looking at deploying ASP.NET Blazor WebAssembly to GitHub pages. So Blazor WebAssembly, you actually, when you're deploying out to a host, you can host just about anywhere, but you're hosting static files. And so you need to include that build step. And you need to do the full kind of publish pipeline in order for that to work. And so here he goes through and looks at how to set that up, starting with the Blazor WebAssembly, pushing out to GitHub. And then he sets this up using a GitHub action workflow. So here he shows creating that workflow with the .NET Core SDK, and then setting that up. So here he's got his job using Ubuntu latest, and just going through the publish thing. So this was a thing that tripped me up when I first looked at this. Was I was thinking I just build and I'm all set to go, and you actually do need to publish out the WebAssembly. So. So then just kind of wrapping up, going through the commit, and showing all the stuff, with branch management, et cetera. So there is some stuff involved here, but once you get the kind of setup going, and here you see his final YAML is not too complex, and then you have the whole kind of publish pipeline. So, all right, and then I think the last one on my kind of front end blob at the beginning here, we've got adding Signalr to a Vue JS app. So here he talks about some things relatively straightforward. A few things to look at. You do need to handle the mapping hub. You need to map the hub so that it's the endpoints are managed between front and back end and the Signalr stuff. That is also a nice thing over, I guess that was ASP.NET Core 2.2.1. I don't know, but the endpoint kind of move definitely simplified things.
That was 3.0.
3.0? Okay. It's a blur. It's moving fast. Thanks, Chris. So one other thing that he points out in here is this library he's using, which is a Vue Signalr library he found on NPM that simplifies the mapping stuff. So then once he's actually running it, it's pretty straightforward. Front end code for Signalr is generally pretty short usually. So So there you go. All right, here's a fun one from Yosef. So recently, there was a change. We all moved over, knowing or not, from using Newtonsoft.json to system.text.json. In most cases, that sped up everything. System.text.json is generally faster and allocates a lot less, but it does handle things like serialization and deserialization a little differently. And so here he had a bug report come in where somebody, they were assuming that something was serialized into, a name, and it was actually still, a dictionary, and it wasn't being deserialized the same way. So what he ends up doing in this post, and there's a decent amount of code here as a lot of serializing and deserializing code goes, but he actually wrote a custom deserializer for system.text.json for his objects. So here he goes through and shows his JSON converter and talks about the things extracting values and mapping values back and forth. Here he shows here's his actual JSON object, and the end result after writing the serialization code is that he's able to model or to map back and forth. Also, he shows the benchmarks, and it's nice to see that, like I was mentioning earlier, both faster and generally a lot less allocation too. So cool. All right, here's a quick one. This is just on running and debugging .NET Core with WSL2 from Visual Studio. So this has been available for a bit, but people are maybe not as aware. You can both you can set up WSL2. You can then go into Visual Studio using the VS extension to debug with WSL2, and then let me see. Then he just goes through and runs it, and here he's debugging against Unix, and that's all there is to it. So pretty straightforward, really kind of lightweight way to be testing against a Unix backend.
Nice.
All right, here's a cool article from Julie Lehrman, and here she's writing about transforming an ASP.NET Core API into an AWS Lambda function. So a lot of this is just mapping the terminology and mapping things over into running with AWS. So she talks about creating the API project, copying assets over, and then she's actually going in, let me see, and she's running as a Lambda function. So she's actually creating using the project and the publish thing. So the AWS tooling for Visual Studio is actually pretty good, I've found. And so here going through and creating the publish handles a lot of the stuff. And then she kind of wraps up with what actually got created in the portal, in the AWS portal. So, as good reminder as a .NET Core developer, your stuff runs everywhere. We were just, previous post was looking at WSL and Unix, and here's AWS. So .NET superpower, running all over the place and in all the clouds is a good thing. Christos here. So Christos, PM on identity, and here he's writing about securing gRPC services with .NET Core and Azure AD. So here, writing, it's, both writing the gRPC application and then setting up all the stuff. So usually with this, I end up going through and checking out the docs. There's identity stuff that can be complicated to figure out. But the tooling has kind of simplified over time, so that's nice. So anyhow, he's after having created that, then he creates a service and creates the API. And code authentication, and there you go. So and the grand finale is hello SpongeBob, and the code's up on GitHub. So yeah, so Nice that these are there. Electric Havoc, by the way, calls out. Nice to see that these links are on live.asp.net and live.net, and that's true that we actually include these in the show descriptions, and we have code that parses them out. So if you go to live.asp.net or live.net, then it actually includes that in the page itself. So what he's talking about there, if we go to live.net, I'll just drag this over and share the screen. Boop. So you'll see in these, for all of these down here where it says community links. So here's the community links. You can click on this and see them right now. So pro tip. All right, let me crank through. As always, I'm like, oh, I don't know if I have many links this week. And then when I review, I'm like, I have too many links this week. So this is cool. This is Jerry writing about running ASP.NET Core on an Azure B1 of IS or LS VM. So just talking about things to do as far as running on a small VM. And, you know, it's always interesting as you're going through and shrinking things down and running. So here he talks about, you know, that you can, but it needs to be, you know, very slim and tiny one. This one, I did see some comments too. People are like, yeah, you're really kind of pushing it up against the limits on that VM. But so, all right. So VMs are difficult. Let's move to Docker. And there we go. Scott Hanselman's been doing these kind of intro videos. So here's one where he's talking about Docker. And this is kind of the Docker basics. And so cool. And then just also make sure you're following his series because he's going through and doing great kind of overview videos for these sorts of things. Once you do Docker, then you get pulled. It's the gateway drug to Kubernetes. And so here's a long post. We already had a post by Andrew Locke on Kubernetes. And so here he's going through and doing an intro to Kubernetes. We've been talking a lot about Kubernetes and Ty recently. Here, what I like about this post is Andrew's going through and just defining the terms. He's got terms and diagrams. So explaining kind of what all the different things are, the nodes and the pods and stuff. So
he's asking the critical question there, which is, how much do I need to learn?
You know,
that's the problem with Kubernetes is like you delve into it and you're then like,
Right, exactly. And I've totally found like I'll gloss over the wrong parts and then I'll think, oh, I've got enough of this. And there's some parts you can skim and some parts you can't. So I've definitely like, why isn't this running or why is my machine overheating and stuff? Yeah. So this is a great, you know, grab a cup of coffee, sit down and read through. So we've moved from VMs are hard, let's go Docker, and then from Docker to Kubernetes. And then from Kubernetes, you want to move maybe to Ty, because Ty simplifies quite a bit of stuff. So Dave Brock has been doing this series on Project Ty, and here he's looking at actually deploying to Kubernetes with Project Ty. So an important thing that he talks through in here, and this is something I kind of tripped through as I kind of skimmed the docs and tried to run through really quickly, is that you do need to have Docker, a container registry, and Kubernetes installed. So I ended up using Minikube on my MacBook, but the docs are really good on this, the Project Ty docs, but you do actually need to read through those. So he talks through, he sets up in Azure using Azure AKS and creating a cluster, and it goes through. I actually ran through using Minikube locally. So that's interesting. So we've got some questions already on Yarp, and we will throw them right over to them as soon as I wrap up these. And I'm just about done with my community links here. So here he goes through and shows deploying. And this is a really cool thing too. The deploy interactive shows kind of, it's a step-by-step kind of command line wizard where it asks you, you know, what do you want to do and where do you want to deploy to? So I definitely did like using that. It was kind of a lightweight thing. Also, an important thing at the end of these sorts of things is to clean up. Otherwise, you can end up running a Kubernetes cluster for a lot longer than you meant to, and spending maybe a lot more money than you wanted to. So this is definitely useful. So I love this series from Dave. Keep them coming, and also great references at the end here. All right. CLTO 3.0 is out. I saw a tweet from Cecil Phillip this morning on that. So, we've been talking through the microservices kind of section of these community links, and CLTO adds a lot of kind of tooling and stuff for microservices with .NET Core. So stuff like RabbitMQ messaging, that is definitely a handy thing. And then integration with Kubernetes as well. So a lot of great stuff in CLTO, and this is, like mentions, there's interoperability with Cloud Foundry, but there's quite a bit more to it. So CLTO is definitely, if you're doing kind of advanced microservices, if you're handling a lot of things like resiliency and like interoperability between multiple microservices, CLTO is a pretty advanced system for dealing with that. So pretty cool. All right, and then two more left. Here we've got ASP.NET Core updates in .NET 5 Preview 8. So what's cool with these community stand-ups is we've already had demos on just about all of this stuff, which is pretty neat. Definitely some stuff like we just recently featured, we had a Blazor deep dive where they previewed a lot of this stuff. So that's pretty cool, like CSS isolation for Blazor components. We had the team on, so check out recent .NET community stand-ups, also lazy loading, etc. So there's information on how to update and what's in all the Blazor things. And then, things like model binding validation with record types, which is so cool. I'm excited about that. And then, just some other things, JSON console logger, etc. So definitely, try it out, give feedback to the team. Preview 8, it's getting close. And the last post I have to share by Sam, and this is from back in May, which is the Introducing Yarp Preview 1. And some cool stuff in here. But rather than dig deeply into this, why don't we just jump over to you folks and we'll get the latest and greatest. What is this Yarp thing?
So Yarp is a reverse proxy. You may be familiar with regular proxies, which are kind of sit between your organization and the internet and used for outbound traffic. A reverse proxy is the opposite. So it sits on the edge between the internet and your data center. It is the front end that the public sees, and it can then map those requests from the internet over to individual servers. Actually, can we show the slide?
Yes. There we go.
Sorry. Only a couple slides, uses demonstrations. So a request can come in and it can say, oh, I want /customers. Reverse proxy listens to that, looks at the URL, and then can go and load balance that across a set of different servers. And so it's basically looking at the headers of the request, and based on any of the fields there, can decide how to route that traffic. It has the advantage of the load balance between servers. You get health checking, so if a server's down, it won't send traffic to that. But also you can offload work from those backend servers onto the reverse proxy. Encryption, auth, compression, caching, and then also you can collect metrics and logging at the reverse proxy. So particularly if you have a heterogeneous set of services written in different languages, different environments, sticking a reverse proxy in front of them means that you can remap the URLs as you need to, but also you can collect metrics and logging regardless of what that backend system is using.
Okay. All right. I'm trying to think of intelligent questions, but I think I'll have more as you keep showing things. So
yeah, those are proxies in general.
Yeah.
Now what?
Yarp is a reverse proxy built on ASP.NET. So we had a number of teams come to us. I work on the networking side of .NET. Chris works on ASP.NET, and they came to us independently, basically asking, how do we build reverse proxies? And so after having a couple of teams come to us, it was like, we probably ought to do something here. So what we're doing is we're using ASP.NET as the front end, and then adding a new component into the middleware pipeline of ASP.NET that is the reverse proxy, and that in turn has its own little pipeline, and that then uses HTTP client to go request the data from the backend services.
Okay.
You had your next slide?
I do have another slide. That's me to switch. So one of the other scenarios that people use reverse proxies in is what they call the service mesh. So again, really good for heterogeneous services. Example here, I've got two hosts, one hosting service 1, 2, and 3, and the other hosting service ABC. And let's assume that service 1 wants to talk to service B. It doesn't necessarily know, or sorry, oh, my diagram is wrong according to my clients. Oh, I hadn't noticed that before. Okay, so it wants to call across to service A. Rather than it having to know which servers actually handle service A, it could just talk to localhost and say, hey, send this request to service A. The mesh proxy there will knows about all the other mesh proxies, and so basically says, hey, host 2, I think you've got a service A, so it sends the request to go over to the mesh proxy on host 2, and that goes, oh yeah, I know about service A, and then goes and talks to the individual port for service A or service B in this case. And this is commonly done with containers as sidecars. So there's popular technologies like Envoy and Istio that build on top of that, producing service mesh networks. So the key difference between Yarp and these other services is what we heard from people internally, the teams internally that want to proxy, is generally they want to do something a little bit weird. And so they want to be able to write code. And the problem with the existing proxy solutions is they're generally C++. And so you're either using an extensibility system of like Java, JavaScript, or Lua. But all our own teams are using .NET, and they want to be able to write .NET code. And they also want that extensibility to be fast. And so that's where Yarp comes in. We have our own little pipeline as part of Yarp that does load balancing, health checks, request transformation, those other pieces. And so you can either modify the existing components or add and insert your own. If you want to do authentication or other pieces, you can do all that using that pipeline.
Okay. So, and then I'm sure, of course, it's got to be fast enough, right? That like that, if you're inserting things and it's running as part of a proxy, people would, of course, be worried about how fast that code's going to run.
Mm-hmm.
Yeah.
Any proxy is going to add overhead. Sam, you want to show your one more slide you had?
Yes, good prompting. So we have not yet done a deep dive into the perf of Yarp, but we have a great benchmark lab that we run internally, and so we're actually tracking the perf of a couple of different competitive proxies and Yarp. We're not quite there yet with a red line in this compared to the others. But we would believe we can be competitive with Envoy and Nginx at least, if not HA proxy.
Yeah, that light blue line on the chart is what you would get if you stripped down Kestrel and HTTP client to the bare minimum. And Yarp with the orange line has all the routing and infrastructure in between. And so we expect we can get most of the way up to that blue line.
Nice. Okay. Yeah. So the blue line's kind of the theoretical max, right? Because that's
the theoretical max using existing Kestrel and existing HTTP client.
Got it.
And
right.
we've even been making improvements in those.
Yeah.
Okay.
So one of the other goals of this project is to use Yarp as a forcing function to actually drill into both Kestrel and HTTP client and ensure that we can get the perf where we need it in these places.
Okay.
So we've already been doing a bunch of work on that in the .NET 5 timeframe. Actually, we've been making less progress on Yarp over the last couple of months because the resources have been working on getting those features into .NET 5 so that we can take advantage of them in Yarp.
Okay.
Mm-hmm. And .NET 5 just locked down for RC, so you're going to start seeing a lot more churn in Yarp.
Okay. All right. Now that that's locked, you're able to kind of, okay.
Focus.
Yeah.
Focus.
Yeah.
Okay.
It's kind of one of those things of like, is that work the stuff that I would do highest priority for Yarp right now? No, but if we don't get it done in .NET 5, we'll have to wait for it in .NET 6, and so we front loaded it because of the way the scheduling works.
Okay. All right. Cool. There's some interesting kind of down in the, a little bit like technical questions here. One is a question here like, how's this different from Ocelot? I don't know all these kind of different, proxy things. That's
a really, so Ocelot is a reverse proxy and an API gateway. The big difference and the thing that Ocelot does is it will actually interpret and crack the body of the HTTP requests and responses. One of the decisions we made in Yarp is we're not doing that in V1. It means that we can stream the content directly from the client to the back end and the back end back. We don't need to buffer it. Once you do buffer it, it has perf impacts, but there are pros and cons to that. It has perf impact, but then you can do interesting things like rewriting that request, redoing the body. So Ocelot can take a request and split it and send that to two individual servers and then merge the responses back together again.
Okay.
So what we do in Yarp is we just work off we kind of decided our line is we'll work off the headers, not the body of the request. We pass that through as fast as we can.
Okay. Cool. Okay, that makes sense. Do you want to go over to some demos, or?
Yeah.
I'm interested to see what the code looks like how I'm actually, using Yarp.
Yeah, and I think a lot of the questions will lean into that.
Chris.
All right.
Okay, let me switch over to your screen then, Chris.
There we go. Okay. So this is just starting off with your typical ASP.NET Core app. Everything, they all have startup, you use config, great, and you start adding your services. In this case, you're going to add a reverse proxy, and you're going to load the settings for that proxy from your config file. And the only other thing you really need to do is to go down here and add endpoints. You're going to say, I'm going to add my reverse proxy endpoints based on what I loaded in from config. There's lots of room for extensibility in here, but that's the bare minimum to get started. So let's go look at the config. So this ought to look really familiar. Every ASP.NET Core template does this. And then people wanting to configure Kestrel can start adding these endpoints here. So this is just an ASP.NET Core app. It's listening on HTTPS 5001, HTTP 5000. All right. And then we get into the Yarp fun. So we said we're using the reverse proxy section over here.
Mm-hmm.
So here we go. We start with a list of routes. These go into the ASP.NET route table with these criteria. So I'm going to match everything for example and getter post. And I'm going to send them over to cluster 1. And we'll go look at cluster 1 in a moment. I also have a rule that says I'm going to match everything for localhost and send it over to cluster 2. But for this route, I'm also going to munch the headers a little bit. I'm going to add a request header, foobar. I'm going to add a response header, foobar. And I'm going to add an HTTP2 response trailer. So just some simple things you can mess with in a request.
So I'm not familiar. What is a response trailer? Is that in the? What does that mean?
They are officially they're headers that come after the body.
Okay.
That you can use to generate things like e-tags and
So
just additional data that you computed while sending the body.
Is that a new? But is it still sent in the header of the document, or is this now one of these weird?
It's sent after the body.
Okay.
So it's kind of like I send my headers, I send my body, and then oops, here's a couple of other headers I forgot to send earlier, or I figured out as I've been going along.
Okay.
Officially, this has been in the specs since HTTP 1.1 with chunking, but nobody implemented it or used it. But HTTP 2 brought it back as a primary feature, and Grpc is actually requiring it.
Okay.
Grpc streaming sends a status code in the trailers at the end of the stream.
Okay.
Yeah.
Yep.
To report the final conclusion of your stream. Did it exit gracefully? Did it get killed? Whatever. Okay. So the clusters. A cluster has a couple simple options. We've got load balancing built in. We have session affinity components. And then a cluster is primarily a group of destinations. And each destination has its address. Every request sent to cluster 1 is going to be forwarded to example.com using HTTPS.
Okay.
If you want to do front end TLS termination and just do HTTP in the back end, you delete the S.
Okay. So you're handling that. You're just proxying it at that point. Okay.
Yeah.
Cool. Yeah.
The proxy doesn't have to do anything special for TLS termination. That's just a configuration.
Okay. Yep.
And then cluster 2, we're going to handle these on localhost. And we've got 2 destinations here that we'll be load balancing between.
Okay. All right. And then with load balancing, there's things like, I don't know, round robin, and like how do you handle that? Who actually does it map to?
Exactly. I just put it right here. The default we use is random.
Nice.
And then
but you put that one in cluster 1 that only has one destination.
There's a couple others built in, and we have some backlog work to go in and make that fully extensible.
Okay.
So you can specify. The most interesting one people keep asking for is least busy powers of 2. Is that what it was called?
Yeah, so you pick 2. It's like pick 2 randomly and then use the least busy of the 2 of them.
Oh, interesting.
So that you don't have to look through the whole list or maintain some complicated structure, but you also don't accidentally randomly choose the busiest node.
Yeah, okay.
Because it turns out that round robin is actually not the best. You'd think it's the best, the best load balancing, but there's a bunch of research that round robin is actually the worst.
Okay.
Because you can't individual requests don't tend to have the same impact. All requests don't have the same impact, and so it just ends up with one server getting pegged.
Okay. All right. So you mentioned future extensibility. Would that maybe then I could write my own algorithm or whatever for, okay.
Yep. And you would load that as a service in startup and then reference it by name here. And away you go.
Okay.
That is an entertaining notion that should be down here, but it's just the default, so I don't think it really matters.
Okay. Let me see.
All right, so let's actually run these. So the first one is easy. It's going to go out to example.com. But for the second one, I'm going to start up my other sample server. This is just another ASP.NET Core Kestrel web app. And it has one interesting controller that's going to dump out all the request fields so we can see what the forwarded request looks like. Okay, so you're up and running. Then we're going to run this guy as our actual proxy. Whoop. Okay, I'm just going to point out a few logs here that say, hey, we're loading data from config. We found a destination and a cluster and more destinations and routes. Cool, we are up and running. Okay.
All right.
So we got forwarded to that endpoint that is using HTTP2 by default between the front end and the back end.
Okay.
Which you need HTTPS to do unless you're doing some crazy stuff.
Okay. And HTTP2 is there. So obviously there's enough support for it. Because I know earlier there's different places like Windows support for HTTP2 and stuff like that, right?
Basic support for HTTP2 has been available on Windows since Windows 10's very first release.
Okay.
Grpc I mentioned the other day uses trailers, which wasn't supported in that first release and is only now just coming into support in insider previews.
Okay.
Kestrel doesn't depend on almost any of the Windows features except SSL. And so Kestrel supported HTTP2 with trailers and all the features all the way back in 2.2, I think. You could opt into it.
Okay.
Anyways, we were routed over all our fun request headers, including the one that we asked the proxy to add for us. And a few that the proxy added automatically. Let me zoom in here.
Yeah.
These are our forwarders saying the original request was also HTTPS and was sent to localhost 5001 at from IP address IPv6 localhost. IPv6.
So, and those are kind of standard proxy headers.
These are de facto standards.
Okay.
Yeah. There's actually a new standard that that's just called forwarded. And we have already implemented that. It's just not turned on by default here because everyone uses these.
Okay. So interesting question from Dave here. You're showing using configuration using JSON. And I asked a little question about like, overriding for algorithms, but what about like, are there other ways to can you configure in code?
Oh, absolutely. That's the second demo.
Okay.
This one is just easier to read.
Yeah. Yeah, that makes sense.
And I'll just point out a few other things before we take off.
Sure.
And to the other one. Let's see. We talked about load balancing, transforms, TLS termination. Let me do one more here. Oh, actually, let me just show. Hey, look, I'm missing Standup. This was the other route we had mapped. this is going out to example.com. And the page comes back and it looks just like example.com, except if you go look in the network,
that reminds me, I need to renew my domain registration for example.com, or a lot of websites are going to break. Need to go pay GoDaddy.
Wait, what? Anyways, the one thing I just wanted to show here is, where is our response headers? Why am I getting a 404 but despite getting the page? Oh well. We'll mulligan that demo.
Well, so that's actually, I'll just ask now, if you have like a 404, that makes me think of how can this potentially integrate in with health checks? Because that's also
health checks are a fundamental feature of proxies.
Okay.
And in fact, say I've got two destinations here. The first check in the proxy pipeline is, do I know if any of these destinations are unhealthy? In which case, I will eliminate them from the list, and I won't even try to pass those to the load balancing algorithm.
Okay.
If you end up with 0, well, that's a problem too.
Yeah.
But hard to load balance across 0. All right, so this server's up and running. I just want to tweak one thing. Just going to say, what if I want to route example 2 instead? Oh, that's not the right server. That's not the right server either. That one. Where's my config reload? It was there a minute ago. Oh well. I'll demo that one later.
But we're supposed to have live config reload. So if you change the config file, the server will pick it up and update the routes and everything dynamically based on that. Which is partly the answer to the question that was just asked, but there's actually a better system,
right?
Which is work item number 8 that Chris will now demonstrate.
That Sam was tracking for so long he memorized.
Yeah.
Those ones.
Okay.
Nice.
So yeah, let's code over to the code example. Because yes, config files are cheap and easy, but that's not actually what any of our partners have asked for. Mm-hmm. It was just a good starting point while we got the rest of the infrastructure up and running. I'm going to kill that one. All right. So this starts the same. I've got a startup, I've got a config, but I'm just going to hand roll these routes and clusters and pretend I pulled them in from a database or something. The one thing you have to specify on a route is a path or a host. And a cluster needs a destination. Same kind of data that you saw in the config. And then I added, let me fast forward a little bit. You still have map reverse proxy, but this sample is showing some of the extensibility. We'll come back to that in a minute.
Yep.
And then I added this fun little thing that is just load from memory. And all I'm doing is I'm registering a proxy config provider in the DI container.
Ooh.
And here is the cheap config provider I implemented. All it does is it implements one method that says, give me the current config. And that config has a change notification on it that says, tell me when this config is expired and I should reload a new one. And
Okay.
it's got my routes, it's got my clusters. And this one even technically supports reload, where I could just hand it new routes and clusters, and it would say the old one has expired, here's a new one. And the proxy is going to load up this interface from DI. It's going to say, please give me the config, and then it's going to sit and listen for changes.
Okay.
So you have live reload, you have the ability to load these things from anywhere you want. And we'll talk about some of the places people are looking at doing that. I saw more than one question about, what was it, Kubernetes Ingress? That's definitely something on the backlog.
And that will basically use this system to add and modify the routes as the Kubernetes configuration changes.
Okay.
I'm going to go ahead and run this, but I mean, it really demos exactly the same. Whee! I still got my request. We didn't add any forwarders this time, but we still have our defaults. And yeah, good. That one's not 404ing. Yep. And we can still proxy over to... I didn't define the example route in this demo, did I? Oh, okay. So that's loading from code. Let's look at a few of the other extensibility points real quick. So in the other sample, you saw map reverse proxy was just a single line. And when you do that single line, it includes a few canned defaults, such as session affinity and load balancing.
Mm-hmm.
These are, for the most part, these are somewhat normal ASP.NET Core middleware. And if you've written some middleware examples, you recognize this pattern. This is the HTTP context, and that's the next middleware.
Okay.
Yeah. And so, but within the proxy, you get your own private pipeline that says, I can run middleware in any order I want to customize anything I want. For example, I can run stuff before or after the load balancer. And this particular example is grabbing out some of the proxy request state that says, what are the current available destinations for this request on this cluster? And you know how I mentioned like the health checks? Those have already been, the unhealthy destinations have already been filtered out from this list. And this is the same list that the load balancer is going to look at. So if you want to do some custom load balancing or something, and you say, I really want this request to end up on node 6, you can just specify that right here. And the load balancing will look at the list and say, there's only one element left. I guess that's the one I have to choose.
Okay.
And then the request gets forwarded at the end here. There's a middleware hiding at the end of this pipeline that is the actual proxy middleware that invokes HTTP client and forwards over the request.
Okay. All right. So, all right. I'm trying to think how. So, this is a kind of very lightweight thing where you can do like an inline one, and of course,
this is inline. Yeah.
Yeah.
And the same middleware pattern works for classes and all that other fun stuff.
Okay. Wow.
This is just very visible.
Yep. Interesting. Wow. Man, a lot of questions coming in. I'm not sure which is which to go for here. Some let me see. So questions on using callbacks. Is callbacks a pattern, or I guess this is all done kind of on, you're kind of mapping your endpoint to kind of on startup, right? So
callbacks rather than config. So there is a third scenario that we've had customers ask for, which says, I don't know what my routes are up front, or there's just too many to load.
Mm-hmm.
How do I run a callback on every request and assign the right route? And we've got some theories going. No, not a lot of code to share yet. Although the standing theory is that you end up adding one catch-all route in the table, and then you end up just writing a simple middleware like this that says, no, I know where it belongs. I'll take care of it.
Okay.
So Azure functions and websites are examples of this, where they host many domains, and they don't know up front which they can't cache all that information up front.
Oh,
but
right.
also dynamically they'll be spinning, like if sam.com hasn't been used in a long time, that may not be running, and so they'll see, like, oh, I don't have that in entry, let me go talk to the back end, and that will actually go randomly pick a server to spin it up on, and then tell that information back, and then the proxy can then go and redirect the request to the correct backend server.
Okay, so whoops, the wrong one here. I want this one. So I think that you've just covered this, but this is a question of programmatically changing without restarting the proxy.
Yep, that's what I was getting at back here.
Yep. Okay.
If you are loading your routes through code, if you want to reload routes, all you do is you provide a new, where's the method? You provide a new iProxy config instance that has your routes on it, and a change token that says, here we go, the data's changed, please reload.
Okay. All right, I see. So that's how you invalidate, basically. You say, like, yeah, like you said, data's changed.
These routes, these clusters, when do I need to ask for new ones? When does the proxy need to load new ones?
Okay. Interesting. Okay, some questions here on, like, for instance, secret management, and I'm not sure how that would fit in. Is there?
So, because this is integrated into ASP.NET Core, we don't actually have to worry about most of that stuff, because you use the existing ASP.NET Core components to manage that. Use the existing data protection and config providers to load all those things.
So that, I think that shows kind of the value, because there are other proxies out there, but here what you're showing is this, because this is running integrated in with the ASP.NET Core ecosystem and pipeline and everything, then you get all that kind of for free, including if you're running it.
Middleware. You can put in, I have one more sample here for authorization that we can get to.
Sure.
Yeah. But let's go through some questions first, because I haven't heard anyone ask about that.
Yeah, well, actually, I mean, this is a lead-in one here, but, question on authentication.
Oh,
yeah, there you go. So, yeah, I mean, like, for instance, this same person, Christopher Gay, and then he asked about, most apps are running with Identity Server 4, for instance. So how does that simplify that kind of interaction?
Identity Server 4, it plugs directly into ASP.NET Core. So you can plug that in here normally. And let me just switch over to my auth example. This is a copy of the config example. Load from config. And I will show the one interesting difference, where I have said that this route uses the default authorization policy, and this route uses a custom one.
Oh.
And that's about it.
Wow.
And then in Startup, you are using existing ASP.NET Core authentication and authorization. Here's the custom policy we referenced. It says you have to have some special claim to go down this route. ASP.NET's default authorization policy just says you have to be authenticated. I don't really care how. And so
Okay.
we can run this demo real quick.
So if I'm understanding this right, if I'm not authenticated at that level, we can map to a different endpoint.
That's true. You can
Okay.
have an unauthenticated route as well.
Interesting.
And the routes are ordered, so I assume if you put the authenticated one first, it will. If you're not authenticated, it'll fail and bubble through to the next.
Mm-hmm. So I just tried to go to the root site, and I was not authenticated, and so the proxy intercepted that and sent me over to a account controller in the proxy that says you should probably log in.
Oh, interesting. Okay, so pushing that authentication into the proxy itself.
Right.
Yes.
And so if you want to do Identity Server 4, you can either do that inside the proxy or using OpenID Connect or something in the proxy and having the Identity Server as another sidecar.
Interesting. So then my application itself, I mean, I'd still need to program defensively, but I could kind of basically write my application assuming I'm going to get an authenticated user.
Mm-hmm.
And what you can actually do is pass claims and things as headers through from the proxy to the back end. And the back end can then use that as long as it trusts the proxy, knows, oh, I'm going to be told exactly who the user is or which groups they're member of or whatever other information you want.
Here is your front end's auth cookie that just was forwarded by default to the back end. If they need to crack that open and look for user data.
Okay.
You can also make JOT tokens and forward them or anything else you want to do.
Okay. So one kind of holy grail question we always get is we have people that are migrating large applications that were originally written with ASP.NET Web Forms or MVC2 or whatever, and they're moving over to ASP.NET Core, and they're trying to synthesize it into one front-end app, and they're maybe creating some services that are running ASP.NET Core, but they want it, the whole kind of like, oh, the admin section is still web forms, but the front end, whatever. Does this help with that?
Any proxy would help with that, yeah.
Okay.
If you can break it down to discrete routes, then yeah, you should be able to move it piecemeal.
Are you able to talk at all about any of the, like you mentioned, some of this was internal people at Microsoft that are using this. Can you talk about the sorts of applications that they're building or?
Yeah, so I was talking to a team just last week who were doing exactly the authentication case. They had an internal website that was using good old-fashioned password auth, and they wanted Active Directory integration. So they're actually using Yarp to authenticate to the front end. They then block on the website. It can only be accessed via the proxy and pass through information that way.
Okay.
And they were like, yeah, there was one feature they needed that came in the last preview, and they're now deployed internally and happy.
So what about for people watching that are interested in playing with this or using this? There's the previous blog post that you did. How do people get involved in, like, start testing it and using it?
So we are doing monthly previews in sync with .NET 5. We can run on either .NET 5 or Core 3.1. The samples are all up on our GitHub, which is GitHub/Microsoft /proxy.
Okay.
All right, and here's the GitHub page I'm sharing. And here is the releases we've got out. The getting started gets updated for each release. And it just walks you through, make a new app, add the dependency, add the stuff to startup. And here's a starting config. Run with it.
What do you see as some of the main, like, where is this a good fit and a bad fit, especially at this point? for people that may be, interested in trying this out? What are the kind of slam dunk easy things, or the things that are not, you shouldn't look at for this point? Like, I know you've been overviewing a lot what it does. You've just shown all the different features, but I'm just trying to think of for people that are interested in looking at like, for instance, you showed performance is good, but it's not like as high as some competitors at this point, and there's some things you're still working on. So what's the you should absolutely try it for this sort of thing, or you should kind of hold on it for other sorts of things?
The pro is customization. Being able to get in there, write C#, mess with requests, control where they're loaded, where your routes are loaded from, all that fun stuff. That's ready and running today. And doing something like that in Nginx would be kind of a pain.
Okay.
I would say like, we have the basic functionality, the core fundamentals in there now. We're going to be improving things like the metrics and logging, being able to do A/B switching. So if you have a new version of your service, people will stick a reverse proxy in front of that and say, let me just send 1% of my traffic to the new version. I'll check how that's going, and then slowly ramp that up, and then switch over from the old version to the new version. That's a feature that we're working on right now.
That's very cool.
Health checks. So there's both active and passive health checks. Active is like, let me go ping the destination every 30 seconds or whatever, make sure it's live. Passive is, let me look at the requests and the responses coming back there and ensuring that I'm not getting server errors. Individual response errors may be correct, but it's kind of, how do I interpret that and then decide that there's a problem with that server or not.
And to be clear, neither version of those health checks are currently available.
Okay. But that's kind of the sweet spot of what this is built for long term, right?
Yes.
We've got a lot of stuff on our roadmap, and we'll be incrementally adding it over the next couple of months.
Yeah. So on GitHub, we have a project board that shows what we're doing in each individual milestone and the backlog. And you can see what we've done and what we're doing based on that.
Okay, cool. Oh yeah, so I could go back. So Chris was sharing here. So can you show that you were saying that's the roadmap, or that's the backlog?
Yeah. So if you just switch to the previous tab.
Yep. So
and then
you want to go into issues?
Projects.
Projects.
Good old GitHub projects. A lot of people aren't aware of these. I really like these for managing.
So these are the ones we're working on this milestone. Customizing the outbound HTTP client, dealing with some of the errors, dealing with some of the metrics. This 1.0 backlog are things we know we need to address before we can release a stable version.
Okay.
And that's a long list of things you should keep an eye on. And if there's something in there you need sooner than later, please let us know.
Is Lino's asking this question, if I understand correctly, saying, when will switching to a new version of a service be available? So I think this is handling, like, handing off live as an app.
A/B testing and live migrations is in here somewhere. I'm expecting to work on that in maybe preview 7 after we get through a couple of blocking issues. And so that would put us in, September, October, November timeframe.
Okay. Another question here, WebSocket support.
Yes.
Cool. Yes, that's an easy answer.
The other one that people ask about with that is gRPC streaming. Yes.
Or gRPC and gRPC streaming, and we do both.
Cool. Here's a question. Let me see. So asking, and I think you covered this while I was troubleshooting Twitch stuff.
No, I got it.
Okay.
Yarp currently targets ASP.NET Core 3.1 and 5.0 so that we can light up some 5.0 functionality. So we can't release before 5.0 comes out in November. But in this case, we are more feature-driven than we are deadline-driven. So we're going to release 1.0 when we get through this list and it actually works.
Okay. Makes sense.
With incrementally more capable previews until we get there.
Yeah.
Hopefully by the end of the year, but...
Yeah. We're trying to be in the same rough time frame as 5.0, but if a preview release has what you need in it, and you don't want to take on 5, just run it on 3.1.
Okay.
Our goal is to light up some additional functionality we want in 5. It's more kind of about improving perf or improving metrics collection
or metrics, right?
There's not dealing with SNI and certs is another feature in 5, but the core functionality should all be there on 3.1.
Okay.
We were asked by one of our internal partners, like, we kind of want to deploy Yarp, but we don't want to take on too many moving targets at once. And that's why we added 3.1 back.
So there's a question here, and I know you covered this, but what specific load balancing strategies are available? And you did talk about custom ones as a future thing, but there we go. Can you make that bigger?
A little bit. And this you can find in the API docs right now.
Cool. Okay, there we go. Interesting. Yeah, that Power 2 choice. I hadn't heard of that one. That is a neat one. Cool. All right. Let me think. I had one other question. So how does this integrate in with things like Project Tie and just kind of microservice-y stuff?
My coworker, Justin, is one of the devs on Tie. And
cool.
Justin
Kotalik. He's been on. Yep. Cool.
Yeah. And he is looking at recycling a lot of what we're doing here into Tie. But I don't think he's had time to try it recently.
Okay. Yeah,
there's a lot of overlap in being able to forward requests to all the right places.
Yeah, and it'd be really interesting to see, like, have the dashboard support that they've got in Tie and that sort of thing, like have this, like kind of management layer.
And yes, that is something on our backlog, is because you can just run more controllers in the proxy. You can put in those status dashboards and things.
Yeah.
Okay. Wow.
So I think we have like 3 different work items. It's kind of like, let's have the internal API, let's have a REST endpoint for that, and then a status dashboard built on top of that.
Oh yeah, the REST endpoint would be really nice, right?
Yeah. For being able to like configure and get the Yarp status.
Okay. Cool. Well, I think we've covered all the kind of main questions that I've seen, and you've talked about the kind of when it's shipping and how to follow along. Anything else you want to cover before we wrap up?
I think there were a number of questions that we didn't get to the details on. But if people want to ping us, you can ping us on the discussions on our GitHub repo, or you can ping me directly on Twitter. John, where can we share that?
Yeah, so there's the chat thing, or so I always have to. Is it TRATCHER? Or you can send it in private chat also.
There, I just put it on my name.
Wonderful. That's the way to do it. Cool. Yep, and you're also included in the show notes on this. It's listed there, and we're doing some work also on the page for this that'll actually. Thank you, Sam. That'll actually make it so that they're included more in with the actual show listings. So very cool. This is since the first post I've been like, oh, we got to get you folks on the show and learn more about this. So, and I really love the idea of like, this totally makes sense to me now of how integrating in with the ASP.NET pipeline really simplifies a lot of things, and being able to write custom .NET code to manage like, distribution and the failover and all that kind of stuff sounds really neat. So
yeah, it turns out like everyone's deployment is not it's not perfect, it's not straightforward, and you need to do some like, here's the point of where you can just hack and make those little tweaks and changes that you need.
Mm-hmm. Okay. All right. Well, I think that's a great place to wrap up. So thanks a bunch. And then let us know in the future as you get, get closer to release, or if there's more stuff to show off. A lot of great questions and excitement from the community as we're doing these. So, happy to have you back on.
Cool. Thank you very much.
All right. Thanks a bunch. That's it for this week. We're now every Tuesday, Wednesday, and Thursday of every week. So we've got so many community stand-ups. So keep following along, and thanks a lot, folks.